Welcome to the Explainer, everyone. We walk around every single day feeling like the ground beneath our feet is just, well, permanent, right? An immovable fixture. But actually, the Earth is essentially this gigantic, churning ball of semi-molten rock. Literally, at its very center, there's a heart of iron that is as hot as the surface of the sun. There's just a titanic amount of heat left over from the birth of our planet, plus the continuous radioactive decay of trillions of tons of elements. And all of that energy has absolutely nowhere to go but up. So you have these massive currents of deep rock spanning thousands of kilometers constantly carrying this unimaginable energy right up towards the surface.
And the only thing standing in the way of all that unimaginable energy? Our crust. Now, it might feel completely rock solid to you and me, but relatively speaking, it's incredibly fragile. Think of it like a thin apple skin wrapped around a fiery, churning behemoth. And every so often, true apocalypses can break right through that apple skin. We're talking about eruptions that are tens of times more powerful than all of our nuclear weapons combined. Events that can literally subject the global climate to centuries' worth of change in a single year, drowning entire continents in toxic ash and gas. So how exactly does this happen? Let's figure it out.
Section 1. Where volcanoes come from and the tectonic struggle.
Okay, let's dive right into this and look at where this incredible force actually comes from. Volcanoes obviously come in a ton of different shapes and sizes, from those towering, majestic mountains to low, creeping lava domes. But they primarily originate from two main sources bubbling just beneath our feet. First up, tectonic plates. Imagine the Earth's crust as a giant jigsaw puzzle made of 7 huge pieces and dozens of smaller ones. They're constantly drifting and grinding against each other at speeds of up to 15 centimeters a year, which I know sounds like a snail's pace, but on a geological timeline, it is a violent, titanic struggle over who gets to stay on the surface. When these plates collide, the winner crumples up to form new mountain ranges, while the loser is violently shoved downward into what's called the asthenosphere, a terrifying ocean of rock sitting at a blistering 1,300 degrees Celsius. Then, on the flip side, we have mantle plumes, which operate completely differently. Plumes are these columns of abnormally hot rock rising all the way from the planet's core. Think of them like ancient rock storms, hundreds of millions of years old, functioning like weather patterns deep in the mantle. They move completely independently of tectonic plates, rising at just a few millimeters a month, and they can punch right through the middle of a plate to create volcanoes seemingly out of nowhere.
So, how does this whole tectonic struggle actually build into an eruption? Well, when that losing tectonic plate gets shoved down into that unimaginably hot underworld, it drags thousands of years' worth of ocean water right down with it. The extreme heat and pressure cause that water to trigger these intense chemical transformations, literally melting the solid rock into liquid magma. And because this liquid magma is less dense than the solid rock around it, it fiercely bubbles upward, pooling into these giant sponge-like reservoirs just beneath the crust. When the pressure in there gets too high, it violently pierces the crust. Geologists almost poetically describe this as a revenge attack by this submerged plate before it's completely melted away and erased forever.
Section 2. Scaling the boom. The Volcanic Explosivity Index. Now that we know how the magma gets there, how do we actually measure the explosion itself? Well, scientists love to categorize things, right? And for volcanoes, they use the Volcanic Explosivity Index, or VEI. It's a logarithmic scale that measures the sheer volume of material ejected during an eruption. And let me tell you, it escalates incredibly fast. For example, a VEI-2 eruption is considered relatively small, but it still ejects enough lava to fill 400 entire Olympic swimming pools. Just picture that. And we experience about 10 of these around the world every single year.
But if we skip just 3 levels ahead to a VEI-5, the scale becomes almost incomprehensible. A really good recent example is the 2022 Hungatunga eruption. At VEI-5, a volcano is blasting the equivalent of an entire lake's worth of molten rock and debris straight up into the atmosphere. The Hungatunga eruption was so massive, it literally sent atmospheric shockwaves circling the entire globe multiple times, and even created massive ocean tsunamis.
And this brilliantly illustrates how things escalate when we move up just 1 or 2 more steps to VEI-6 and 7, where eruptions quite literally change the world. A VEI-6 event, like the infamous 1883 eruption of Krakatoa, produced the loudest sound in recorded history. It was calculated to be 10 trillion times louder than a rocket taking off. It triggered 30-meter-high tsunamis and dropped global temperatures by half a degree Celsius. But even more terrifying is a VEI-7. This is a supercolossal, millennium-defining event. When Mount Tambora exploded in 1815, it released 400 times the energy of the Tsar Bomba, the largest nuclear weapon ever detonated.
It blasted 140 billion tons of ash into the sky, literally turning the world's atmosphere a sickly yellow. It caused the infamous year without a summer, which led to massive crop failures and over 100,000 tragic deaths worldwide.
Moving on to Section 3, the supervolcano myth.
Okay, so hearing about that kind of devastation naturally brings us to a term we hear thrown around all the time in movies and on the news. When you hear the words supervolcano, what exactly comes to your mind? Do you immediately picture some world-ending, unavoidable, apocalyptic doom? I bet you do, because that is exactly what pop culture wants you to think.
But the reality? It's actually quite different. The term supervolcano is literally just a media invention. It is not an official scientific classification at all. We use it casually to describe these colossal magma reservoirs, several kilometers deep, that build up pressure for hundreds of thousands of years. But the huge misconception here is that every single eruption from one of these sites is a world-ending super-eruption. In reality, they act a lot more like a boiling pot of water that just rattles its lid and spits a little bit of steam off the top from time to time.
So, the crucial point here is understanding the mechanics of a true supereruption when it finally does happen. Here's how it goes down. Step 1. The pressure in that massive magma reservoir becomes so unbelievably great that it actually lifts the solid bedrock above it by several meters. Step 2. The rocks crack under the immense strain, giving way to an insane supersonic blast that ejects over 1,000 cubic kilometers of gas and ash right into the sky. And finally, Step 3. With all that material suddenly gone, the ground above collapses into the newly emptied void, forming a giant crater known as a caldera. Then pressure slowly starts building under that caldera all over again. It's a cycle that takes on average about 17,000 years to repeat.
Section 4. Monsters of the Past.
To truly grasp the scale of these events, we really have to look backward at the geological timeline of the greatest monsters of the past. This timeline really puts things in perspective. Just 26,500 years ago, New Zealand experienced the Orunui eruption. It scooped out an Everest-sized chunk of the landscape and just threw it into the sky. Yet remarkably, geologists consider that just a mere firework compared to what happened 74,000 years ago at Lake Toba in South Asia. Toba released a gargantuan 5,300 cubic kilometers of material. It blanketed parts of Asia in 15 centimeters of ash, triggered a rapid 4-degree global temperature drop, and possibly sparked a 10-year volcanic winter. But even Toba completely pales in comparison to the Siberian traps 250 million years ago. Now, this wasn't a sudden explosion. It was a continuous flood of lava that lasted for 2 million years. It raised ocean temperatures to 40 degrees Celsius and caused a mass extinction event that wiped out over 90% of all species on Earth. As the source material beautifully puts it, eruptions of that scale don't just change the climate, they are the climate.
Section 5. Agents for Good. The Future of Volcanic Threat.
Now, thankfully, we haven't seen anything even close to those ancient monsters in hundreds of millions of years. But looking toward the future naturally brings up modern fears surrounding famous geological sites like Yellowstone. Should you be terrified of it ending humanity tomorrow? No way, definitely not. Now, what's really interesting here is that yes, Yellowstone will erupt again someday, but likely as a much smaller event. When it comes to a massive, civilization-threatening VEI-8 super eruption, there is actually less than a 2% chance of that happening in the next few centuries. That's a 98% chance of absolute safety. And more importantly, if it were building up, it wouldn't be a sudden surprise. We would know long before it ever happened.
That safety is completely thanks to human ingenuity. We're actively monitoring ground swelling and temperature increases to give us early warnings. But we aren't just sitting around watching. Scientists are proactively developing solutions for the future. We're looking into technologies to physically remove sulfur and ash from the stratosphere if an eruption does occur, effectively neutralizing the climate disruption. And we can even go a step further. We're exploring ways to exploit these giant magma reservoirs for limitless clean geothermal energy. Just think about what we're already achieving as a species. We have literally successfully redirected asteroids in space. Taming the effects of a volcano is absolutely within our future grasp.
Which leaves us with this final, really provocative thought. Can we turn the Earth's churning hell into our greatest asset? As we continue to advance, we might just transform the ultimate force of destruction into an engine for our own survival. So, while an angry, fiery behemoth is indeed churning deep below us, human determination is stronger. Rest assured you can sleep very well tonight. Thank you so much for joining me for this explainer